Alright class, in this video I'm going to show you some of the introduction to forensics, some of the important court cases that you've seen, what forensic scientists do, and the history of it. So what is forensic science? Forensic science is the application of science and technology to those criminal and civil laws that are enforced by police agencies in a criminal justice system. When you're looking at forensics, you're trying to solve something that happened in the past. Now that could or could not necessarily be a crime. In most cases it is, and that's why it's usually law enforcement involved. There are a lot of major sciences involved in forensics. Typically forensics will be a science that you take either your junior or senior year after you've taken the following. Definitely a lot of chemistry involved, examining the chemical makeup of substances found at a crime scene. You can look at toxicology reports for people and their death due to drugs and other chemicals. Also look at biology, that's examining biological properties of substances, maybe hair samples or DNA samples, blood typing. So there's a lot of chemistry and biology involved in forensics. You also have physics, looking at, say, ballistics or different projectiles and how they might affect the body, examining the movement or impact of materials. And you also could look at geology, examining Earth's components when important to a crime scene investigation. Sometimes you'll see a dead body from many years ago, and looking at the bone structures or looking at the rocks nearby could determine time and cause of death. Some of the basic overview of the history of forensics. First person to start the whole trend of using forensics to solve crimes was actually an author, Sir Arthur Conan Doyle, who made the fictional character of Sherlock Holmes. You might have seen the movies with Robert Downey Jr. there. He first applied principles of serology, looking at blood, fingerprinting, firearm identification, if you know what bullet or gun came from, and question document examination, seeing how certain handwriting signatures might vary or be similar to others. You also have Francis Galton. He was one of the first people to study fingerprints and developed a method of classifying them. He noticed that everyone has their own individual fingerprint, their uniqueness, even up to identical twins. You'll see another video on fingerprints on the YouTube page. Next, you also have Edmund Locard. He was an advocate of the use of the scientific method in criminal investigations. He actually had a background in medicine and in law, so he tried to tie into using evidence in the law rooms. And he is famous for the Locard's exchange principle. Locard's exchange principle essentially says that there will always be a trace of evidence from one person to the next as you collect data in a crime scene. Some examples are, if you have medical particles carried on clothing from a crime scene, can link the suspect to a crime. Obviously, if you see some metal particles in someone's shoe and they're the same metal particles that caused the death, you could link the two together. Soil samples found in a vehicle could link the suspect to a crime scene as well. Looking at tire marks, if you see the soil has certain bacteria in it, next to a dead body, similar bacteria, that also can link them. Plant material found on cars or clothing can link a suspect. Pollen, hair samples, even microscopic trace evidence, which I do another video on, could link them as well. Next we're going to look at crime labs. Crime labs can be in the direction of a lot of different departments depending on the size of the city and the resources they have. It could be under the police department. Sometimes it's under the lawyers, so the prosecutors or DA's office. In many cases in big cities, it'll be in the coroner's or medical examiner's office. And it even could be with some universities as testing facilities. Sometimes in a small town, they might bring a blood sample to the university because they don't have the resources there to test it. In a full-service crime lab, these are in major cities in America, you'll have 5 different sections. One's a physical science unit. This applies principles of chemistry, physics, and geology to identify and compare evidence. Examples looking at drug chemistry identification, seeing what chemicals are in a drug, soil mineral analysis, and physical properties of trace evidence, looking at bullet marks, stab wounds, and whatnot. Another part is you'll have the biology unit, that's staff of biologists and biochemists. apply their knowledge to the biological aspects. Examples are DNA identification, dried blood stains, looking at body fluids and comparing them to a victim, hair and fiber comparisons, especially with the hair, and identification of plant material, insects that go with them as well. The third part is you'll have your firearms unit. They're responsible for examination of the firearms, discharged bullets, seeing the casing, shotgun shells, and ammunition. They'll look at the casings again, residue in the gunshot, the target length and where the impact was located, and also tool marks, could be other wounds besides guns. There's a whole separate video I made on firearms that you can check out as well. Next, you have a document examination unit. They study typewriting and also handwriting on some question documents to determine authenticity about who it is or the source. It looks at handwriting identification, analysis of different inks or papers used, indentations, that's other markings, and erasure marks to actually determine someone erased other papers. You also have a photography unit. One of the first people that come in are the photographers before they touch the evidence. It's used to examine and record physical evidence, looking at digital imaging, infrared imaging, if there's certain things that they can't see with the human eye, ultraviolet imaging as well, and X-ray photography, looking at different bone structures and whatnot. One of the major court cases to determine that forensic evidence could be used in a court of law was Frye versus the United States. This was a court case that established what type of rules scientific evidence has to follow to be allowed. It said that scientific procedures will only be allowed in a court of law if the procedures used are generally accepted by the scientific community. This also helps establish the accuracy and validity of the tests and results easy to understand by all scientists. What I mean by generally accepted, there are certain best practices used by the scientific community in terms of how to properly collect data, how to properly set up the lab stations to see your data. And as long as that has been followed, then it can be allowed in a court of law. It will not be allowed in a court of law if these are not followed. So how are generally accepted procedures determined? It's based on expert witnesses, that might be an expert in the field, books, other resources that have a lot of evidence to prove it, documented studies along with the books if they're showing actual studies showing what happens, and your case history, seeing previous court cases that are very similar to the one on trial. Speaking of expert witnesses, an expert witness has a knowledge, skill, experience, training, or education that lends itself directly to understanding the scientific evidence. They could be people that work in that field, or they could just be experts in the field of study, not necessarily as a forensic scientist. So if you talk to an advanced chemist who works with chemistry for a living, he would be able to do some basic toxicology reports, because that's what he does in his living. So most experts do not have forensic science degrees. Most will have degrees in the specific science discipline. A biologist that studies the DNA of different plants and animals can be used as an expert witness in a DNA trial. Training and experience is also a large part of being qualified. So just being out in the field doing a lot of the things that they're explaining about will show that they're an expert witness. And when expert witnesses actually testify in front of a jury for a trial, the evidence, they want to evaluate it that the court lacks expertise to do so. Judges and lawyers aren't experts in DNA evidence, so that's why they bring the witnesses in. They express an opinion of the significance of the findings. You cannot have absolute certainty. You could just say beyond a reasonable doubt, I think that this DNA shows that this is the suspect. Okay. Now, based on expert witnesses, if you have a lot of them all saying the same opinion based on the studies that they did, that shows pretty confident evidence that someone might have committed a crime. Going along with expert witnesses, collecting evidence is also very important. You have to collect evidence correctly and preserve properly. That'll be the next video I show in this series. Some labs have evidence collection teams, or CSI, crime scene investigators. They are trained by lab staff to gather important physical evidence at your crime scene. Then they work in the lab to continue the exposure to the procedures And very importantly, use proper tools and supplies for collection and packaging of evidence. In the class, you'll be doing quite a bit of this, just as a review on how to properly collect evidence, because if it's not collected properly, then it could be deemed inadmissible in court and it can't be used as evidence. Alright class, so that just gives a basic overview of forensic science. If you have any questions, leave a comment down below.